This podcast is brought to you by LMU Munich.
Okay, hi. Welcome to the Alpha Room. Now we will start the talk by Andreas Jung. He's going to talk about NoSQL databases.
Hi, good morning. Thank you. This is perhaps the only talk that doesn't feature Python so much. So I'm talking tomorrow about SQL databases, in particular about Arangodb. Anyone heard of Arangodb? Are you using it? Okay. So, some words about myself. I'm a pretty long Python developer since 1993. I have a long history in Zope and Plone development, and I'm basically focused my work on electronic publishing solutions, stuff like PDF generations, publishing workflows in the field, and also founded several projects in the field of publishing, like XML Director and Prism Publish, but that's not the topic of my talk. First, disclaimer of this talk: it's completely biased, it's completely opinionated, it's unscientific, and may contain some traces of Python. And I just want to mention that I'm not affiliated with Arangodb, the company behind, in any way. So let's get started. I guess every one of you has used a relational database in the past in some way. Relational database around since the mid-70s. The first relational database was a system called R by IBM in 1974. And then the first commercial relational database was Oracle, peaked in 1979. And the relational database model is pretty well understood. Has been researched, lots of papers, and it's pretty common in the database in our industry since almost 40 years. And there is a standard called SQL for structured query language, which is also an ISO standard in several variations, evolved over several years. And in theory, all databases based on SQL should be in some way interoperable, but as you know, there are lots of extensions. Every database has its own extensions, and so to some degree, they work together. So, but what means NoSQL? NoSQL means not SQL. That's wrong, because SQL is just a query language. NoSQL basically means your data model is not relational. Basically, all databases which are not relational are NoSQL in some way. So, just to quote Jan Lennart, which is one of the maintainers of CouchDB, he defines NoSQL is not about performance, scaling, dropping ACID, or hitting SQL. It's about choice. NoSQL databases give you an opportunity to have different options apart from relational databases for implementing particular requirements, for scaling, and give you various options to implement better functionality. It doesn't help you to compare features like throughput, performance, efficiency, and so on. In general, you want to think about what are your particular requirements and projects, what you have requirements for scaling, for building your architecture, and so on. And therefore, NoSQL databases just give you the opportunity, a bigger pool of opportunities for building your database applications. So when we're talking about, do we have a laser pointer? No, we don't. When we talk about NoSQL databases, there are various categories. In general, you can distinguish between key value stores like memcached, which basically memcached, Redis, or RAIAC. We have column-oriented databases like Cassandra. Then we have the typical document storage, which basically store JSON typically, like MongoDB or CouchDB, but also very specialized databases like Bigtable, HBase, which are more about tabular data, or graph databases like Neo4j, are very specific databases, for example, for XML, storing XML. There are stuff like XSDB, BaseX, and so on and so forth. So why NoSQL databases? As I said, we had 40 years relational databases, but over the last 10 years or so, the cloud evolved more and more. We have got big data. You have to deal with replication. Your data applications might be running in different data centers, either in one country or across the world. You have to deal with distribution, replication, and so on, and different kind of data, like time series or huge documents, and so on, a combination of that. And for this purpose, we need better solutions. In this context of NoSQL databases, you always will find the CAP theorem. Anyone heard of the CAP theorem? Okay, it's a theorem postulated in 2002 by Eric Brewer. He's a researcher, and he basically published about distributed systems. A theorem that's basically, if you deal with a distributed system, you always have to make two choices. You always have to deal with availability, means that your system always returns a valid response, independent of any failures. You have to deal with consistency. That means every application running queries on the service should basically see the most recent data. And you have to deal with partition tolerance, means in a distributed system, you can have a network split and have various effects, and this means partition tolerance. And the theorem of Eric Brewer basically says you always have to pick two, you can always give two guarantees. Means your system can never be both consistent, available, and be tolerant against partitions. That means that all databases in the field of NoSQL can only implement a certain subset of these three guarantees. For example, Cassandra is widely used and it's highly available, but it doesn't guarantee that every application running a query against Cassandra will always see the same data. That means eventual consistency. And so every database has its own focus on one of these three particular guarantees. So my talk says the hunt for the best or for the right multipurpose database. I was looking into various databases across the several years, and I was looking particularly into databases that could be used in our typical publishing projects, which basically have to do with documents, JSON data, metadata, and so on, not so much about time series data. And I was just looking what was on the market, making some evaluation work, and see what's available. In particular, I was looking into databases which implement some kind of document store, means JSON documents. I want to have some nice query functionality. For example, Elasticsearch offers you JSON as a query language, but that can be very inefficient and very complex to write queries. I was looking into options for implementing relations between documents and data, so some kind of relationship across data. And in most cases, we are interested in solutions having some kind of transaction and async compatibility. So I was looking at these various options. You may see that a lot of databases around here you might know. And in the end, I looked into three different databases in particular. One was FoundationDB, that was bought 2 years ago by Apple, so that's gone. Then I came across a database called MarkLogic Server, which is one of the high-end NoSQL databases. It's very expensive, but it's, from my point of view, one of the best NoSQL databases and systems in the world. In particular, it's very scalable. It has the most feature-rich features of the databases. And for example, it saved the Obamacare project last year, which was granted to Oracle, and Oracle just didn't deliver. And within half a year, they just recreated the complete system with MarkLogic. But as I said, it's high-end and perhaps not so much suited. Let's talk about Arangodb. I came to Arangodb about 1 year ago, and it implements, or it calls itself, a multi-model data store. It has 3 different data models. One is a traditional document store, means you can store your data as JSON. And you have all the functionality you need for updating, inserting, querying, and create secondary index and so on. In addition to that, you can have a traditional key store, key value store. And as a third component, you have a graph database. It means you can create your own JSON documents and create relations in terms of a graph on top of that. And all 3 models can be combined and created in the same way. So that basically these 3 models live side by side happily by each other. And that's one of the strengths of Arangodb. It also gives you a framework called Fox, which allows you to implement REST APIs or REST microservices. They can be written in JavaScript. The JavaScript code just lives within the database or as part of the database. That means the JavaScript code can directly access the underlying data without any network latency, which makes it extremely fast. So with this, you can basically just write your REST services in a very efficient way. You can use all the existing JavaScript tools like Node and so on, the complete stack, and this makes it very attractable for building REST services and based on JavaScript. In addition to that, you have a built-in job queue, can basically perform internal asynchronous tasks and so on. So how do you query or write queries or in Arangodb? They have their own query language called AQL for Arango query language. It's a declarative, human-readable, domain-specific language compared to other systems, for example, like Elasticsearch, which uses JSON for writing queries. That's a big advantage for me because I can just write the queries in a similar way as SQL. We'll see some examples later. And you can use AQL for both document queries, queries on your graph, and joins and so on. And it also supports transactions about multi-collections. So, can you read that? For example, in this case, that's one typical AQL query. In this case, you are querying 2 collections, one collection called users and one collection called friends. And basically performs a join on both collections. And as you see, there is a filter statement, and basically it will return all names of the users collection where the user has the active flag set and the F user also. And it's very easily readable and writable. If you write this in, for example, in JSON, Elasticsearch, that can be very complicated. So readability is a big advantage for me. This query shows some queries on a graph. As you see, you have to write some more lines of code, but it's very much easier to understand what's going on than having a very, very long, deeply nested JSON structure, for example, as in Elasticsearch, we just have to look where are the braces belong to where, and that's pretty fancy for me. So as I said, in distributed systems, you have to deal about with replication, scaling, sharding, and so on. It comes out of the box with an automatic sharding mechanism. That's a typical architecture. There is an agency which basically keeps the state of the complete cluster running. It's based on the Raft consensus protocol, and it basically knows about the complete state of the cluster. It has some node called the coordinators, which basically all clients talk to the coordinators, and the coordinators know where the data is sitting in which nodes. On the lower side, you will see some DB servers, which are called the secondaries, the primaries, which actually hold the data. And the coordinators basically takes the request, executes the query, and reroute the request to the corresponding server, fetch it there, and return it back. And it supports automatic asynchronous and synchronous replication with failover. Some benchmarks. I just can't comment on every detail here, but Arangodb did a pretty extensive benchmark against different systems like MongoDB, Neo4j, Postgres, and RDB. On the first row, you basically see different tests in the horizontal, and then in comparison, we'll see that the red columns, the red table sets are basically results which are worse than the Arangodb, and only in some cases, like the single read or the memory usage, some systems have been better. So, and in particular, these tests have been run against Arangodb version 2. And here's a benchmark against the graph databases. You see the green one represents Arangodb, and the other are lot much slower than Arangodb. So, Python bindings. Python bindings are basically, you can deal with Arangodb through several Python binding modules like PyArango, or there's another module called Python Arango. In general, don't have a laser pointer, there's a command called create collection in line 6, which basically represents a bag, like a table in a relational database. And then you can create several documents, like there's this loop with a range. You can create a document and then just assign the keys and the values as a dict, and then call it, store it as using save. You can also execute AQL queries from Python. So basically just write this AQL code as text and pass it down to a function called AQL query. And the same when you want to query a database using JSON notation. In this case, there's a mechanism called collection fetch by length, by example, which is a pretty stupid name from my point of view, but it is. In this case, it would basically just query a collection where all the species human would be used as a filter. And that's a pretty long query for querying the graph part. Deployment and operations. Arangodb basically can be installed locally. It runs on all decent systems like macOS, Linux, and Windows, I guess. And it provides out-of-the-box support for Docker, of course. You can run and install it on Apache Mesosphere and run it on DCOS, also has pronounced TCOS, which is basically infrastructure built on top of Apache Mesos for creating a virtual distributed data center. So the latest version is Arangodb version 3.0. They have just published version 3.1. One nice feature is then they change their internal format for storing and transferring the data over the wire called VelociPack. It's an optimized, compressed version of JSON compared to comparable to Beason, which comes from MongoDB, but it's more efficient, much more memory saving, and that's a pretty good feature in 3.1. Apart from that, it's very documented. The documentation is always up to date with each release. You get very regular updates and fixes. They provide very good community support, and who's behind Arangodb? It's a company from Cologne, and they basically know what they're doing compared to other companies in the database field, for example, like MongoDB. There are several companies in this field which are basically, well, corrupted by venture capital, in particular MongoDB. And in my point of view, Arangodb is one of these databases right now which basically gives you the features that you need to build a decent application. It's not the fastest, but it gives you the most options. It's pretty flexible, and it's perhaps one of the options that I would use in production. We don't have any project right now running on Arangodb, but we built a prototype earlier this year, and the results, performance-wise, were basically promising. You can get Arangodb in 2 versions. One is a community edition, which basically provides all the features you need. It's not tripled down. It has a full feature set. On top of that, they will give you an enterprise version with some service-level agreements, some support, and they have now some graph component that can basically visualize your graphs in a better way than in the community edition, and some enterprise features they need for integration with LDAP and so on. But in general, you can work very well with the community edition. It has drivers for all decent languages. Don't want to mention them all. And it's already been used in various large deployments. So, I'm on time. Any questions?
Okay. So first of all, thank you. First question.
Hi, did it fit the Jepsen test already? The Jepsen test from AFAR, I can't speak as well.
Kyle Kingsbury. Yes. What was the question?
Did you run the test already, the Jepsen test suite?
I guess version 2 something was tested by Kyle. And he made various fixes, I guess.
Okay. Any more questions? Yeah. Just.
What internal data types does it support?
What?
Internal data types.
Internal data types. In general, it's schemaless. So it can basically, if you have a document that can be represented as JSON, which can basically directly stored.
So only data types which are serializable in JSON can be stored?
Yes. In addition, it has support for full-text searches. It has support for geospatial searches. So you can basically just model the data in JSON and then create arbitrary indexes on top of that for making, for example, searches on geosearches or stuff like that.
So you spoke quickly about Elasticsearch.
Pardon?
You spoke quickly about Elasticsearch in the slides. And can you do full-text search with Arangodb?
It has support for full-text search, but it's not based on Elasticsearch. It's their own implementation. It's not as fancy as Elasticsearch, in particular when you deal with multilingual text like stemming, such stuff. That's perhaps a problem. Perhaps I would use Elasticsearch on top of that if I have some requirement for performing arbitrary full-text searches.
Okay, I don't see any more hands. So big round of applause again for Andreas.
Thank you.